Hello friends, so in today's lecture we'll do what is convergent sequence, my dear, and how we'll make use of the definition of convergent sequence. Let us understand that. Now friends, we are defining convergent sequence. Convergent sequence. Now friends, a sequence AN is said to converge to a limit L if the following condition holds. If the following condition holds. We used to write that mode an minus L is less than epsilon for all n greater than or equal to m. Friends, try to understand that when we are defining a sequence, this n is a natural number. It means I can say that if diagrammatically I say that if I open it, my an will lie between L plus epsilon and L minus epsilon. That is for all n greater than or equal to m. So we can say that eventually when this subscript n is more than m, then the term of the sequence will lie between L minus epsilon and L plus epsilon. So you can say something like that. Graphically, you can say that, suppose this is L minus epsilon and this is L plus epsilon. And now try to understand that. What used to happen? When suppose this n exceed m, that is you can say that am plus 1, am plus 2, and all these terms will lie between the strips. You can say that am will be somewhere here in the strip, am plus 1 will be somewhere here, and am plus 2 somewhat here, like this. So eventually after this stage, all the terms of the sequence will lie between these two strips, and before that the terms may not lie here, so you can say that term somewhat here, like this. So now the friends will understand that what is the significance of n. Now try to understand that. Now we'll apply this definition to the problem, that how we are going to find this n. So you can say that how we'll apply it. Suppose the question is, prove that the sequence 1 by n square converges to 0. Now see how we'll start it, friend. The definition is mode an minus L less than epsilon. We'll let it like this, and then we have to find n. And please note down that this n is depending on epsilon, so we have to find it. So mode 1 by n square minus 0 is less than epsilon. You have taken it. So this way, and since n is a natural number, so there is no need to putting of mode. So 1 by n square is less than epsilon. So one can say that this will imply n square is greater than 1 by epsilon. So this will imply n is greater than 1 by root epsilon. Now friends, if I take my m is a positive integer greater than 1 by root epsilon, then we are done. Okay, so therefore you can say that mode an minus 0 is less than epsilon for all n greater than or equal to m, and my m, I can say that has to be greater than 1 by root epsilon. So you can say that here, so therefore limit n tends to infinity of an is 0. Now friend, let us consider one more example. The question is, prove that the sequence 1 upon 3 to the power n converges to 0. Now my method is almost same, that is mod an minus 0 less than epsilon. I have taken it, that is mod 1 upon 3 raised to power n minus 0 is less than epsilon. Now my search is to get n, so that is 1 upon 3 to the power n is less than epsilon. Now I can say that this will imply 3 to the power n, 3 to the power n is greater than 1 by epsilon. So this will imply if I take log on both sides, then what will happen? N log 3 is greater than log of 1 by epsilon. So I can say that my n must be greater than log 1 by epsilon upon log 3. So what will we do? Choose a positive integer m greater than log 1 by epsilon upon log 3. So hence we have successfully found m, so therefore mod an minus 0 is less than epsilon for all n greater than equal to m. So the friend, this way this definition work. So most of the time the student won't understand it. Now suppose another example, show that limit n tends to infinity to n plus 1 upon n plus 3 is equal to 2. Now we'll use the again the definition. So let epsilon greater than 0 be given. Now that is what we'll do, right? Mod 2n plus 1 upon n plus 3 minus 2 is less than epsilon. Now our search is to find a suitable n. So if I simplify it, then I will be get mod 5 upon n plus 3 is less than epsilon. So you can say that 5 upon n plus 3. Can I say that it is less than 5 upon n? Yes, of course. And we are taking this as less than epsilon. Now see, I can say that this will imply my n is greater than 5 by epsilon. So choose m is greater than 5 by epsilon. So hence mod an minus 2 less than epsilon for all n greater than equal to m. So limit n tends to infinity of an is equal to 2. So friend, this way we apply this definition of the sequence. I hope you understood it. So in the next video we'll do some other interesting fact about this